write a program to generate Fibonacci series. Let us try to understand what is Fibonacci series. Fibonacci series is a series of numbers in which each number, Fibonacci number, is the sum of the two preceding numbers. For example, the series starts with two numbers 0 and 1. So the sum of 0 and 1 makes the next Fibonacci number in the series. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3, 5. 3 plus 5, 8. And this way the series goes on. Fibonacci numbers are named after the Italian mathematician. Let us try to implement this in our program. Define a class, public class fibdemo. Public keyword denotes that the class can be accessible outside the package, anywhere from the system. Class keyword followed with a class name. Class name is fibdemo. Open the brace, close the brace, and write the code inside these two braces. We have two methods in our program, main method and user-defined method named fibseries. Syntax for user-defined method is data type, method name, parenthesis, and parameters as per your logic. When the data type is void, method doesn't return any value. Name of the method is fibseries and it is taking one integer parameter. Open the brace, close the brace, and write the code inside these two braces. We have main method. Main method is entry point for every core Java program, and user-defined method is given call inside the main method according to the logic. In our program, we are going to generate Fibonacci series for 6 numbers. You need to define a variable that will store length of the series. So I want to generate Fibonacci series for 6 numbers. Length of my series is 6. Variable I is declared to store length of the series. How do we declare a variable? Data type, variable name, and you can assign the value int I equal to 6. I is a variable of type int and value 6 is assigned to it. I is used to store the length of the series. So when this statement is executed, memory allocation happens for variable I. Inside the stack memory area, you have a memory frame reserved where local variables belonging to main method are stored. So I is the local variable belonging to main method. I is reserved space and value 6 is stored in here. Next statement is we are creating object of type fibdemo. So why do you need this object? We need this object because we need to invoke user-defined method fibseries, which is a non-static method. Whenever you want to call a non-static method, you need to call it using an object of the class. If you have static method, you don't need to create object of the class. So what is static method? We have separate video on that. For time being, you need to understand the fibseries method we have defined is a non-static method. It is not preceded with static keyword. Hence, you need to create an object and give a call to the method using object. So when this statement is executed, syntax for creating an object is class name, reference variable name. This name can be anything the user wish to write. New keyword. New keyword is used to allocate memory to the object. Fibdemo parenthesis. This is a constructor call. What is a constructor? There is a separate video for that. So at this statement, we have created object of fibdemo. When this object is created, memory will be allocated for object FB. The reference variable FB is created on the stack memory area. Object belongs to main method. Hence, the reference variable FB will be allocated memory inside the memory frame reserved for main method. An actual object is created on the heap. Address of the object is stored inside the reference variable FB. FB is pointing towards the object on the heap. Next statement is we are giving a method call using object FB. FB.fibseries and we are passing I. What is this I? If you look at the definition of fibseries, it is taking one integer parameter. Hence, when you give a method call, you need to pass an integer argument. I is the integer variable storing integer value. We are passing this value to the method fibseries because it is taking one integer parameter. The value of I is retrieved from the memory. Value 6 is retrieved from the memory and passed to the method. So as soon as interpreter sees the method call, control of execution will go to the method definition and the value 6 passed is captured by variable k. Memory allocation will happen for variable k. Variable k belongs to method fibseries. Memory will be allocated for variable k on stack memory area inside the memory frame reserved for local variables of method fibseries. And the value passed, that is value 6, is stored in here. After the memory allocation happens for variable k, control of execution comes inside and the first statement is executed. Here we are defining three variables n1, n2 and variable c of type int. We need variables n1 and n2 to initialize the Fibonacci series. The first value 0 will be stored inside variable n1. So memory allocation will happen for variable n1 and value 0 is stored in here. The second value 1 is stored inside variable n2. So value 1 is stored inside variable n2. And the third variable c is used as a counter variable to iterate the loop and it is initialized to 0. So memory will be allocated for variable c and value 0 will be stored in here. Now the next statement, system.out.print. Here we are not using println method. I am using print method because I want the output to be printed on the same line. If you use println method, the next output is printed on the new line. Inside the double quotation marks, we have written Fibonacci series for first. So this text will be printed to the console, Fibonacci series for first. Variable k will retrieve value 6. So 6 is printed to the console and inside the double quotation marks again number is colon. This is printed to the console. So when this statement is executed, this output is printed. Now the next statement is we have declared one more variable n3. This variable is used to store the next Fibonacci number in the series. So as soon as this statement is executed, memory will be allocated for variable n3 inside the stack memory area belonging to method fib series. Next is the while loop. Whenever we want to execute the code repeatedly, we need to use loop in our program. Here we are using while loop. Syntax for while loop is while keyword inside the parenthesis condition. You also need an increment statement so that the loop iterates. Open the brace, close the brace, and you will be writing the code inside these braces. So the condition is checked, c less than k. The value of c is retrieved from the memory, that is 0. The value of variable k is retrieved from the memory, that is 6. Condition is checked whether 0 less than 6. Condition is true, hence control of execution comes inside. And the first statement is executed. The first statement we are writing is system.out.print method. Here we are not using println method because println method takes the output to the next line and we want the output to be printed on the same line with some space. So I am using print method and I am printing value of n1 followed with some space. So value of n1 is 0. This is printed to the console. 0 is printed to the console and some space is added because we have written in the code. Next statement is n3 equal to n1 plus n2. Value of n1 is 0. Value of n2 is 1. 0 plus 1 is 1. Hence n3 is assigned to 1. So inside the memory, value of n3 is 1. Next is when the first number in the series is printed, that is 0, n1 becomes n2 and n2 becomes n3. So value of n2 is 1. So when this statement is executed, n1 equal to n2, inside the memory, value 0 is replaced with 1. So n1 is now updated with value of n2, that is 1. The next statement executed is n2 equal to n3. Value of n3 is 1. Hence n2 is now updated with value of n3, that is 1. The next statement is c equal to c plus 1. Here the counter is incremented, value of c is 0. The updated value of c is 0 plus 1, that is 1. Hence inside the memory, value of c is updated to 1. Now from here, control of execution goes to the condition statement and the condition is checked for the next iteration. Now the value of c is 1. 1 less than 6, condition is true, control comes inside. System.out.println, value of n1 is printed. Value of n1 is 1. Here the second number in the series is printed with some given space. So in the output, the second number of the series, that is 1, is printed and some space is added. Next statement executed is n3 equal to n1 plus n2. Value of n1 is 1. Value of n2 is 1. Now the value of n3 becomes 2 and now inside the memory the updated value of n3 is 2. The next statement is executed, n1 equal to n2, value of n2 is 1, hence the updated value of n1 is 1, value of n3 becomes n2, value of n3 is 2, now the updated value of n2 is 2. C is incremented, value of C is 1, 1 plus 1 is equal to 2, now the updated value of C is 2 and from here control of the program goes to the condition statement. Now the next iteration happens, value of C is 2, 2 is less than 6, condition is true, control comes inside, system.out.print, value of n1 is printed, value of n1 is 1. So here the third number in the series is printed, that is 1, and some space is added to the output. And the next statement executed is n3 equal to n1 plus n2, that is value of n1 is 1, value of n2 is 2, hence the value of n3 is 3. Now the updated value of n3 is 3. So inside the memory, value of n3 will be updated to 3. The next statement is n1 equal to n2. So value of n2 now becomes n1, hence the updated value of n1 is 2. Next statement is value of n3 now becomes n2, hence the updated value of n2 is 3. Counter is incremented, value of c is 2, 2 plus 1 is 3. Now the updated value of c is 3. From your control of the program goes to the condition statement and the next iteration is executed. Now value of c is 3, 3 less than 6, condition is true, control comes inside, statement is executed, and we print the fourth Fibonacci number in the series, that is n1. Value of n1 is 2, hence 2 is printed to the console and some space is added. You have space over here. Next statement executed is n3 equal to n1 plus n2. Value of n1 is 2, value of n2 is 3, 2 plus 3 is 5. Now the updated value of n3 is 5. Value of n2 now becomes n1, so n1 is assigned 3. So inside the memory, value of n1 is now 3. Value of n3 now becomes n2, so value of n2 is 5. So inside the memory, value of n2 is replaced with 5. Next, the counter is incremented. Value of c is 3, 3 plus 1 is 4. Now the updated value of c is 4. And from here, control of program goes to the condition and the next iteration is executed. Now the counter is 4, 4 less than 6, condition is true. The statement is executed and value of n1 is printed to the console. Value of n1 is 3. Hence the next Fibonacci number in the series is printed to the console and some space is added. The next statement is executed. Value of n1 is 3 plus value of n2 is 5. Hence now the updated value of n3 is 8. So value of n3 becomes 8. The next statement is executed. n1 equal to n2. Value of n2 is 5. Now the updated value of n1 becomes 5. Next statement is executed. Value of n2 is n3, that is 8. Now the updated value of n2 is 8 and the counter is incremented. C equal to c plus. The value of c is 4 plus 1 equal to 5. Hence value of c is updated to 5. From here, control of execution goes to the condition and the next iteration is executed. So now value of c is 5. 5 is less than 6. Condition is true. Control comes inside. System.out.print statement is executed. We are printing value of n1. Value of n1 is 5. Now the next Fibonacci number is printed to the series, that is 5, and some space is added. Next is n3 equal to n1 plus n2. So value of n1 is 5 and value of n2 is 8. So value of n3 is 13. So inside the memory, value of n3 is 13. Next statement is n1 equal to n2. So value of n2 is 8. So inside the memory, value of n1 becomes 8. Next statement is n2 equal to n3. Value of n3 is 13. Hence inside the memory, value of n2 becomes 13. Next is c equal to c plus 1. Value of c is 5 plus 1 is 6. Now the updated value of c is 6. Again the control goes to the condition statement and the condition is checked. Value of c is 6. 6 less than 6. Condition is false. 6 is not less than 6. 6 is equal to 6. So here the condition becomes false, and when the condition of the loop is false, control will not go inside the loop. The loop will be terminated. So this is how you print Fibonacci series for first 6 numbers and it is printed till 5. Even though next numbers are generated, we are not printing the numbers. We are only printing 6 numbers. Hence these numbers will not be printed because the loop condition becomes false. You can also increase the length of the series. Instead of 6, you can print 10, 15, any number of Fibonacci numbers using the same logic. You can accept the length of the series from the user using scanner object. So after this execution, when the loop is terminated, even the execution of the method is completed, the memory allocated for the local variables of fib series method inside the stack memory area, this is released. So the control goes back to the point from where the method was invoked. Memory from the stack is released and there are no further statements to be executed. Hence the main method terminates and the program terminates, and all this memory from the stack is released. So this is how we have generated Fibonacci series for 6 numbers.